This is tutorial for buoyancy. Question 1. A barge is 18.3 meter long, 6.1 meter wide and 2.4 meter deep. When empty, its weight 936.4 kilonewton and its center of gravity is 0.5 meter above the bottom. Is it stable when floating in water? So first, what you need to do is you need to draw the free body diagram of this question. For example, we have a barge like this, so we could draw it is just a rectangular box like this one. We know that the width is 6.1 meter, the height of this one is 2.4 meter, and the length here is 18 point something. So and then please follow this step. First, you need to draw the center of gravity of the object. So in this question, it is mentioned that the center of gravity of this object is 0.5 from the bottom. So bottom means from the bottom plate of the barge here. So it is each locate 0.5 meter. So if the question didn't give you any dimension for the center of gravity, you may draw your center of gravity for the whole object is at the center point. So mean if you have a rectangular box here, it is okay for you to draw the center of gravity at the center of this area. But if the question give you the center of the gravity, so you need to follow the instruction in the question. So and then second step, you need to draw the center of buoyancy of force of buoyancy. So center of buoyancy is the centroid of the submerged area. So this is the submerged area. So however, we don't know what is the depth of the water here. So means we don't know how deep the submerged area of this barge, because from question the 2.4 meter here is the dimension of the barge, not the submerged area of the barge. Okay, so however however we could calculate that one. So that the calculation is like this one. Okay, first we could do the force equilibrium, because we have a barge here, so and then we have a water floating here. So we found that the force of buoyancy works upward like this one, and then the weight with work act downward like this one. So we make the equation, which is the force of buoyancy is equal to weight of the barge. So we could calculate the force of buoyancy by using the equation of rho, g and volume. So we could calculate as this one, which is the rho, g, a and h. So and then we could calculate the weight of the barge. Okay, it is by equation weight is equal to mg, but from the question it is given that barge is 936.4 kilonewton. So it is okay for us to use these numbers. So and then the A here, you know, we are calculating the A and H here is the volume. Okay, so the volume here means if we have a barge like this one, and this is the water, so means that we need to calculate what is the volume of this one. So this is the A here is the length here, okay, in 3D. So let's say you have a barge here like this one, okay, so and then this is the A, or the A is the top part here. Okay, the area is this one, and then we multiply with the h here, so this is h, so we could get the volume. So according to this calculation, we could get that the H is 0.855 meters. So means that from this calculation, we know that H is 0.855 meters. So means that the location of center of buoyancy here is, so the OB here mean the distance from the origin to center of buoyancy. It is equal to H divided by 2. So it is equal to 0.855 meter divided by 2. So this is what you get here. So and then we need to calculate whether the barge is stable or not. Okay, the idea to determine whether it is stable or not is by calculating the GM. So if the GM is greater than 0, so it is stable. So if the distance of G to M, so we say as GM is less than 0, so it's become unstable. So and then if GM is equal to 0, we call it as equilibrium stable. So I will explain about equilibrium stable later on. So and then, as I said in previous lecture, you need to remember the axis like this one. The bottom point is origin, the second one is center of buoyancy, the third one is center of gravity, and the fourth one is the metacenter. So you need to draw to ease the calculation. So please draw this axis in your paper, and then you write OBGM. So and then, okay, we could calculate the distance of G to M here. GM here is equal to BM minus BG. So please remember this equation. So means that GM here, it is equal to BM, the total length from B to M, minus BG. Okay, so I think by drawing the axis there, you could understand how to develop this equation. So and then we could calculate BG, okay, by OG minus OB. So the same idea you could get from this axis, OBGM. So to calculate the BG here, it is equal to OG minus with OB. So this is, the unit is in meter, so means it is a vertical distance from that specific point. Then from this calculation, so our intention, so our aim is to fulfill this equation. So means that we need to know what is the value of GM. So by using this equation, BM minus BG, and we start to calculate the amount of the value of BG first. So the equation for BG is this one. BG is equal OG minus OB, and it can be written as 0.5 minus H over 2. So OG is the distance from origin to gravity. So as you could see here, this is the origin and this is gravity. So it is given in the question as 0.5. So and then we could calculate the value of B here. The distance from origin to B is H over 2. So and then we could calculate the value of H is 0.855 meters, and then we could calculate the value of Bg as 0.0725 meter. So and then we need to calculate the Bm. So in previous notes, I share with you the equation for the Bm. So Bm is equal the moment over the volume. So and this moment, so you need to understand that this moment will reflect how the barge floating. So and then the discussion is like this. So we have a barge here. So we have a box, a rectangular box like this one. Okay, so and then it is floating in water. So and then we need to determine the rotating moment. So and then you could imagine that we have two axes here. Okay, we have this axis. So let's say this is the y-axis and this is the x-axis. You can name it differently. Okay, so and then if the barge is rotating on y-axis, so it will float, it will move like this one. So it will move right to left like this one. So and then if this barge is rotate at x-axis, so it will rotate front and rear like this one. So I hope you could imagine the function of axis in terms of calculating the moment here. So and then you need to make some deduction or some assumption that normally in barge we only focusing on rotating of these axis, because from the front view, if we have a ship here, normally people will analyze the rotating of ship about the in front rotating like this one, because it is very stable for ship for the, if we have another axis here, so it is very stable for ship for the rotating on this axis. Okay, so because we have barge here, so and then it rotate, let's say we have an axis here, and then we are analyzing the rotating of this axis. So means that we need to know the area on the surface of water. So this is the area of on the surface of water. So the area is rectangular. So now our analysis is about the rotating moment of rectangular on this axis. So and then because let's say we have according to here we have a width here. So we have the 6.1 width, and then the length here is 18.3, and then the depth here is a certain amount. Okay, so and then because we are evaluating a moment on this axis, so the equation for moment for rectangular is AB cubed like this one, and then because this axis is passing through the 6.1 meter, so it will become 1/12, 18.3 and 6.1 cube like this one. So I hope students understand how to calculate the moment for this, to calculate the amount of Bm here. So the I here, okay, can be calculated as 1/12 AB cube, and it will become 1/12. A is 18.3, 18.3 and 6.1 cube. So and then the V here is the volume. So again, you must understand that this volume is the displaced volume, not the whole volume of the barge. So the displaced volume can be calculated as this one. So we have 6.1 times 18.3 times 0.855, because 0.855 here is the depth of the submerged area. So and then if we calculate all of this, we could get that it is equal to 3.63 meter. Then we substitute these two parameter into this equation. So GM is equal to BM minus BG. So we substitute the value of BM here and the value of BG. So we found that it is a positive answer, which is 3.5575 meter. Means that the barge is stable.